Okay, so here's another video on some more angles. And these angles we're going to talk about today are complementary, supplementary, and vertical angles. Okay, so here I have a little picture of a house that's being framed, and it all over in this house these angles exist. So there's a bunch of complementary angles in here. There's a bunch of supplementary angles in here, like right here where this sort of ridge line meets these rafters here. And there's also vertical angles all over the place in this picture here. And yeah, so I can't point them out to you right now because you don't know what they are. But let's go ahead and discover what they are real quick. Okay, so first of all is complementary angles. And complementary angles are just simply two angles that add to 90 degrees. So anywhere that you find two angles that add to 90 degrees, they are complementary. So as you look at these two angles, this one here is 60 degrees, and this one is 30 degrees. So because 60 degrees plus 30 degrees equals 90 degrees, we know that these two angles are complementary. Complementary. And that doesn't mean they're free. It just means that they add up to 90 degrees. This is one of those things in math where the English version of something being complementary doesn't apply. But complementary angles in math class are two angles that add to 90 degrees. Okay, so they could be separated like these two, or more frequently you'll see them adjacent, like this example. And so in this example, we're asked to find the measure of angle MOP. Well, this is a complementary angle problem. And the reason that we know it's a complementary angle problem is because this box right here means that angle COP is 90 degrees. So the measure of angle COP, I realize what that spells, be mature, equals 90 degrees. Actually, if you look carefully, what I wanted to spell is comp, which is like an abbreviation for complementary. So as we have the measure of angle COP is 90 degrees, we know that these two angles add up to 90 degrees. So 57, and this is our angle addition postulate again, plus x equals 90 degrees. So in order to solve this equation, we have to subtract 57 from both sides. And 90 minus 57 is going to be 33 degrees. Okay, so the measure of angle MOP is 33 degrees. Now this right here, I did sort of like a equation method to do it, and it would be very important for you to learn how to set these up. So it's just this one plus that one equals the bigger one. But you can also, if you'd like to, use a more intuitive method, which is just we just take 90 minus 57, and we know that it's 33 degrees. You need to be able to do both. Mr. Teller can actually do both of these. And the reason that I would want to do this is if this equation became a little bit more complicated, like if I said this was x plus 5 degrees or something, and then you'd have to do a little bit more math. But for this problem, this method is fine too. Okay. So this is what an example of if they are complementary. And just a reminder, make sure that if you don't have everything written down, you can always go back and pause the video and copy things down to make sure that you have your notes for the future quiz or test that this may be on. Okay, next concept is supplementary angles. Now you see that supplementary and complementary sound very much the same, and I have a little trick to help you memorize them, but I have to be standing in front of you to show you the trick. So make sure that you remind me in class if I don't show you the trick. But these are supplementary angles, and supplementary angles are two angles that add up to 180 degrees. So just like complementary angles, if we look at these two right here, and they add to 180 degrees, which these do, we know that these two angles are supplementary. Okay, good. So once again, they can be separated or they can be stuck together like you can see down here. And when they're stuck together like this, what happens is we actually have an angle right here, MAH. We know that MAH is a straight angle. Okay, so its measurement is actually 180 degrees. And then using our angle addition postulate, we know that x degrees plus 58 degrees is going to be equal to 180 degrees here. So when you see it like this is called a linear pair. And that's two angles that are supplementary and adjacent. So when you see this sort of be a straight line with a line coming to it like that, that would be a linear pair, or if the line slanted the other direction, or if it was straight up and down, all these are linear pairs. Okay, or if it's like sideways like this, this is a linear pair right here, this angle and that one. Okay, so that's what a linear pair is. Okay, so back to our problem. We know that these two add up to 180, so if we want to find the measure of angle MAT, that is going to be x degrees plus 58 degrees equals 180 degrees. Okay, so x plus 58 equals 180. So we're going to subtract 58 degrees from both sides. And 180 minus 58 is going to give us that x is equal to 122 degrees. So once again, here's the algebraic method. If you prefer a more intuitive method, you could do 180 minus 58, and you get the same result. Okay. So we get 122 degrees. All right. So that's a linear pair or supplementary angles there. Okay, next up, we have vertical angles. Now, vertical angles, and I have to fix one little thing here. Just give me one moment. Vertical angles are a little bit harder to explain what they look like. So you'll see, it's just going to take me a second here, that we have this little picture. So if two lines intersect, it should say right here, that's what I'm trying to type in, then vertical angles are equal in measure. Okay, so this whole thing actually is the definition. You have to include this picture, because in order to describe this little picture, it's like almost impossible. But you need this whole thing. So vertical angles are like angle 1 and 2. So notice I put them in green here. So angle 1 and 2 are vertical. Therefore, the measure of angle 1 equals the measure of angle 2. So if you look at this, you can see that these two angles look equal here, and they actually are equal because we have, and they're called vertical angles. You have this intersecting lines, and 1 and 2 are equal. Now remember, intersect just means that they cross. If you don't remember what this word intersect means, it means just that they cross. Okay, so with that same idea, 3 and 4 are also equal. So the measure of angle 3 equals the measure of angle 4, because they also are vertical. Okay? So these two equal each other and these two equal each other, but 1 does not equal 3. That's a linear pair. Those add up to 180, just like the previous ones. But 3 and 4 are actually equal. Okay, so let's take a look at an example problem. All right, so in this problem, we're given these intersecting lines here, and they intersect at point C. And then we have these two angle measurements, and we're asked to find the measure of angle ACD. Okay? Not ACDC, just ACD. Little joke there. Okay, so if you have, this one is 39 degrees, we know that they're equal if they're across from each other like this. And so that means this one here is also 39 degrees. Okay. Pretty simple concept. The important thing to know is that they're across from each other, so they sort of make actually a V, like for vertical angles. So if you look at this sideways, it's a V, or like if you looked here, it would be a V like this. Okay, so these V's, that means they're vertical, right? Okay. And so we'll be practicing these quite a bit. They take a few to get the hang of and get really good at, but you'll get it, I promise.